All right, so we're basically done investigation 1, and at the end of investigation 1, you should be able to perform these 5 skills. Skill number 1, basically you need to find a walking rate based upon some information. I'll show you what that means in a moment. From there, you need to create a table based upon that walking rate. After you create a table, or even if you see a table, you should be able to create an equation that fits for every person. So each person should have their own equation if it's linear, which is what we're dealing with. From there, you should be able to create a graph from that table or that equation, and then answer certain questions, like if they were to walk 30 seconds, how far would they get? If they walked 500 meters. And if you hear that, you can tell I'm recording this in school. All right, so let's get started. Taylor and Joe. Taylor walks 10 meters in 6 seconds. Joe walks 10 meters in 5 seconds. At this point, you should understand that you're looking for a unit rate. You're looking for a walking rate. So first of all, Taylor, she walks 10 meters in 6 seconds versus Joe walking 10 meters in 5 seconds. So we're going to determine their walking rate. Joe's real easy to do. He's 2 meters per second. All right. Taylor's is a little bit more complicated. You need to do 10 divided by 6 in a calculator, and you're going to end up getting 1.6 repeating meters per second. So this was tricking a lot of people. Who's faster? Joe is faster. He's going 2 meters every second. So that means in 1 second, he's getting further than Taylor. Taylor's going 1.6 meters in 1 second. So you can see the division problem is set up when you put the units in. 10 meters per 6 seconds is 1.6, all right? So from there, you would need to create a quick table. So that's what this would look like. All right, so this is what the table would look like. And you can see that here's Joe. He's going from 0 to 2 to 4, 6. And you can see after 10 seconds, he gets 20 meters. Okay, you also see that his walking rate was 10 meters in 5 seconds. That matches right here. Okay, and if you look at Taylor, you can see that each time she's behind Joe. Okay, it's behind. Her walking rate is less, so therefore her distance would be less. So she ends up at 16 meters in 10 seconds, and Joe ends up at 20. So basically, we created a unit rate. We made a table. So you're expected to do that after unit 1. All right, some other things you'll look at is you'll be given a table already, and you have to look at that table, and there's some things you need to keep in mind. All right, this is now, instead of for seconds, this is cycling per hour, and we're talking about distance per mile. You have 3 new people, Jose, Mario, and Melanie. We did this one in class. And you can see that Jose, you can see the walking rate is here. This is per 1. So after 1 hour, it's 5 miles per hour. So Jose would be 5 miles per hour. Okay. You have Mario. He's 7 miles per hour. And then you have Melanie, which is 9 miles per hour. And this is found in this column right here in the table. That one. Another thing to keep in mind is they all start at 0. Not one of them gets a head start. That's really important for you to recognize that they put the 0 in here to let you know that all of them start at the same distance. If you got a head start, that number would be different, but none of them did. You should be able to answer some questions here and creating a formula. A formula would be basically for each student, you use their walking rate. So y equals mx plus b. Right here is their walking rate, and right here is where they begin. All of them begin at 0. Okay, so you don't really have to put that in because they all plus 0, and that's kind of a waste of your time. So each student has a different walking rate. Joe's walking rate is 5x. Mario's is 7x, and Melanie's is 9x. So basically each equation is y equals, and then their walking rate. All right, so that's how you write the equation. The equation is important because if you were to put 7 hours into x, you could solve for each one of these people. So the formula is really helpful. Next, you would be asked to graph, and I'm going to use a little trick in graphing. But before we do that, I do want to show you a graph that looks a little bit different than this. What if you had a graph that didn't all start at 0? All right, so you have running per hour and distance per mile, same kind of a concept. You have Kier, Indy, and Janae. So thing I want you to look at, each one of them. So this is 0. So you'll note right here, this is a little bit different. Janae needs a little bit of help. So she is going to get a 10-hour head start. That's redunculous. 10-hour head start. That's really not fair. Okay? But she's really, really, really slow. So if you're looking at running per hour, Kier, he's starting at 0 distance, Indy 0 and 10. We'll get into what that means for Janae in a minute. Here's their unit rate. But note, this one is special. It's very, very special and it's unique. If you start at 0, life is easy. Kier's walking rate is 5 miles per hour. Okay? And Indy's walking rate is 7 miles per hour because she's faster. Now, it might look that Janae is faster, but in reality, she's only going up +4, okay, which is slower than all of them. All right, so her walking rate is 4 miles per hour. And you see that because she started at 10, this is her rate of change. She went from 10 to 14 to 18 to 22. That's only +4. So you have to be careful. Her walking rate was not 14. It was actually 4. So each one of these people has a formula. Kier's formula is 5x. Indy's formula is 7x. Now, Janae's formula is a little bit different. Hers is 4x plus 10. And this is where it's new. This plus 10 is where she began. And in the formula, y equals mx plus b, y equals mx plus b, this part of the formula right here, the b, is where you begin. You'll notice Kier and Indy did not begin anywhere. They began at 0. So therefore, it would be a waste of time for me to write +0 for these people because +0 doesn't mean anything. +10, on the other hand, if I were to substitute 1 mile in here, 4 times 1 plus 10, that should equal 14, which it does. 4 times 2 is 8 plus 10, that's 18. That's our next time. We'll get into this a little bit more, but I really want you to understand that where you begin is important in your formula. These two formulas are just like before. You don't really need the +0, but that next one is unique. Let me show you what that looks like in a graph. All right, so when looking at the 3, Kier, Indy, and Janae's times, you can see that each one of them has their own slope. Y equals 5x, 7x, and 4x. So 5 is the slope for Kier. He's walking 5 miles in an hour versus, or riding 5 miles in an hour, or 7 miles in an hour, or 4 miles in an hour. So you can kind of see that if all 3 of them just that was it, their starting point would be 0. So I just want you to recognize that. I also want you to see what would happen if we add that additional part. So if somebody got a head start, if someone were to get a head start, for example, right here, 4x plus 10, you can see that that graph shifts over and the plus 10 is where she begins. All right, so the graph kind of looks a little bit different, but the slope is still less. So you can see here, if I kind of zoom out here, you can see that the slope is less for the green line versus the blue line is the highest slope and the red is in the middle. So that's kind of how it's represented in graph form.